In section 7.3, we'll pick up our second gas law, which connects trends in gas volume to temperature at a constant pressure. We'll see how the law was developed, then use it to solve problems. Let's begin. Nearly 100 years after Boyle's discovery, Charles discovered that when the pressure is constant, the volume of a sample of gas varies directly with the absolute, or Kelvin, temperature. The textbook has two videos demonstrating Charles' law. The second one shows what happens when you heat air and capture it inside a balloon. Not only does the hot air rise, but it expands to fill the volume of the container, in this case, the balloon. The first video shows an experimental setup for collecting temperature volume data. Let's review the data collected from such an experiment. Since the relationship between absolute temperature and the volume is direct, we can plot this as volume in liters on the y-axis versus Kelvin temperature on the x-axis. Taking V over T will give us a fairly constant value, depending on how good the data set is. We can write Charles' law in a more useful form. Recognizing that the volume in liters equals the Kelvin temperature times a constant value, K, we can say that the volume divided by the temperature under one set of conditions equals the new volume divided by the new temperature under a second set of conditions. Let's try this out in a practice problem. A 678 milliliter sample of gas, initially at 0 Celsius, is heated at constant pressure, achieving a final volume of 0.896 liters. What is the final temperature in Celsius? To solve this, tabulate the data and convert to like units. In this case, we need everything in terms of Kelvin temperature and liters. The missing variable is T2, so we'll rearrange Charles' law, V1 over T1 equals V2 over T2, to solve for T2, where T2 equals T1 V2 over V1. Dropping in the numbers, we get T2 equals 273.15 Kelvin times 0.896 liters divided by 0.678 liters equals 361 Kelvin. Notice I went ahead and dropped the 0.15 Kelvin since we only get 3 sig figs. Converting back to Celsius, we have 361 Kelvin minus 273 equals 88 degrees Celsius. Finally, I'll leave you with the parting thoughts of the authors.